Hi there. Thank you for clicking on this video. This video is the second video in our study of complex numbers, and this video is going to focus on operations. Please like this video if you find it helpful, subscribe for more math help, and check out the other videos we have on the channel, including complex numbers part 1 and the practice set for this lesson. So as I mentioned, this is the second part of kind of two parts on complex numbers. So if you've clicked on this and we start rolling on the lesson and you realize this is not what you were looking for, this does not line up with what you're covering in class, please check out the first part of this, which will lay the foundation for what is an I and what can we do with it. So what are complex numbers? The first lesson was titled complex numbers, and we really just kind of got into imaginary numbers with that. In this lesson, we're actually going to define what a complex number is. Well, complex numbers have a real part and they have an imaginary part, and that's I guess the piece that makes them complex. Almost wish we didn't have that name for it. They take the form a plus bi, okay? And the a is the real part, meaning it's a number like not attached to an imaginary number, and the bi is the imaginary part. And they'd be added together. Okay, now one of them could be negative, so you could see a minus sign there. And typically that's the form that they have to take. So if you have a graphing calculator, say a Casio or a TI or some other model of graphing calculator, you will see a plus bi as like a mode, as something that you can put your calculator in. Desmos does not, at the time of this recording, handle imaginary numbers. So you are kind of on your own for being able to operate with them, unless you have a graphing calculator that has that mode in it. So what are some examples of complex numbers? Well, it could be something as simple as 3 plus 5i. Okay, that would be considered a complex number. The numbers could be negative. So you could have -2 minus 4i. Just remember that would be -2 plus -4i. Just remember our definition of subtraction. And the a and the b are any kind of real numbers. So they could be decimals. So you could have like 0.5, or you could have a fraction like 0.5 plus 1/4 i. Okay, but essentially that's the form that they're going to take, and your final answer for any kind of problem it should be in that form. And that's all a complex number is. So if you know what real numbers are and you know what imaginary numbers are, then complex numbers are not typically an issue. So rules for operating. So operations, just so we're clear on what we mean by that, operations are add, subtract, multiplying, and dividing. So how do you add, subtract, multiply, and divide with these complex numbers? Mostly we have really good news. Treat the I like a variable. Now, a variable like X or Y represents an unknown number, okay? But remember that in an expression like 2x plus 4, the X does indeed represent a number. We just don't know what it is, and we hold the position with like a letter. The I represents a known number, but the key piece of that is that it still represents a number. And so because it still represents a number, it behaves the same way. It doesn't matter whether the number is known or unknown. You've got this letter in your expression, and all the rules that you know for operating with things with X's in them are also going to apply to I's. Okay, the fact that we just know that I happens to be the square root of -1 does not change any of that. So that's a really good news. When you encounter an I squared, remember that the I squared is equal to -1 and make that substitution. So if you're working with X's and you have an X squared, you just kind of have to leave it as an X squared. But because again, I is a known number, when you encounter an I squared, okay, you just have to remember, oh, that's right, I squared is equal to -1, and go ahead and make that substitution. And lastly, when you are dividing, remember that we cannot have square roots in the denominator of a fraction. And so when we're dividing, if you have something like 2 plus 3i over 2 minus 5i, that really what that is 2 minus 5 square root of -1. And so we're not allowed to have that square root of -1. And so division is pretty much, how do I get out of that? So where I have that I. Now, if all of that just was way over your head and you're realizing, I don't know what she's talking about at all, go and check out the video for part 1. Okay, I'm going to link that right up there. Just means you need to be back up a lesson so that you are aware, like, what is I squared, and that sort of thing. All right. So I'm just going to walk you through some examples and I'll talk through them as I am working them out. Now, one of the things that's true about complex numbers, and I have this on a later slide, complex numbers are often in parentheses. They are not necessarily operational parentheses. Okay, so these are what I typically tell my students are cosmetic parentheses. And if you think about cosmetics, say, you wear mascara or eyeshadow or something like that, it changes what your eyes will look like, but it does not change what they are or how they work. In the same way, these parentheses here are cosmetic. They are performing the function of separating the two complex numbers from each other. So 3 plus 4i and 6 minus 7i, but they don't do anything mathematically. They don't actually change how that expression works. So when you're adding complex numbers, you can simply remove the parentheses. Okay, you just simply get rid of them. And then it becomes an issue of combining like terms. And so if you've got your real numbers, there we go, your real numbers, so 3 plus 6 would be one operation, and then you have a positive 4i, just don't forget it's positive, minus 7i, and you would just simply carry out that operation. So 3 plus 6 is 9, and 4i minus 7i is negative 3i, or you could write 9 minus 3i. Either one of those forms is fine. All right, so that's pretty much it. I've never ever had students have issues with adding complex numbers unless they forget that they are adding. And that is actually fairly common. So I'll talk about that at the end of the lesson. So that's all there is to it. You just add or subtract like the real numbers and add or subtract the imaginary numbers, however the signs dictate. Now, with subtraction, this is a little bit different. The parentheses in a subtraction problem are not actually cosmetic, okay? Meaning that they do perform a operational value or operational function here. And that is because they group this complex number together and we're subtracting the entire complex number. So if you remember, subtraction means to add the opposite. I need to add the opposite of everything in those parentheses. In other words, I need to distribute that subtraction. I need to subtract 6, and then I also need to subtract negative 7i. Okay, so we are subtracting the 6 and the negative 7i, and it might help you to like remember this is plus a negative, and this is also going to be like plus a negative, or you might think of it as plus -1, and you're going to distribute that through. So you've got to distribute that negative through. In the long run, short run, I don't know. The first set of parentheses we can just drop. There's no operation on that first set. It's the second set that is problematic. And I'm going to clean that up because I kind of cluttered it a little bit. I am distributing this subtraction through. So I will be doing minus 6 and minus negative 7i, which is plus 7i. If that is an issue for you, you want to go back and review subtraction of polynomials, or maybe some of your sign rules, like for what you do when you're subtracting a parenthesis. All right, and it's the same deal from here on out. So we've got like the real pieces. So I have 3 minus 6, and then I have my imaginary pieces, which are plus 4i plus 7i. And so 3 minus 6 is negative 3, and 4i plus 7i is 11i. And there we go. So we have our subtraction problem. Multiplication gets more fun. Now, multiplication, you don't see any other operator there, okay? So if you don't see an operator, that means you're timesing it or multiplying it. And I am, if you followed along with my other videos, I am an advocate of using the area model when multiplying binomials, but you certainly don't have to do it that way. Okay, and so 6 times 3 is 18. 6 times 4i is 24i. 3 times negative 7i is negative 21i. And negative 7i times 4i is negative 28i squared. So all the things you know about multiplying with, say, x's also apply to your y. So I times I gives you I squared, just like x times x gives you x squared. And then we're going to add all of these together. So we have 18 plus 24i minus 21i minus 28i squared. Now, most students will do this when they recopy it. They will say 24 minus 21 is 3. And so they would copy it down like this. And then they might also make this substitution right here. The I squared that you see right there is equal to a -1. So that was that rule, like when you encounter an I squared, that will be substituted out with a -1. And what that does is it allows us to keep going in this problem. So we have 18 plus 3i, -28 times -1 is positive 28. And then positive 28 plus 18 is 46. So we end up 46 plus 3i. Now I did that out in 4 steps plus my scratch work over here to the side. You can do it in fewer steps. So a lot of students would skip this step right here, and they would use that body of work to kind of launch into this step here. I don't encourage that you try to find shortcuts. I have had students, not usually students that I had for this content, but students that I might encounter in a later class, and they'll say, oh, you just flip the sign. Well, yes, you flip the sign, but the reason you flip the sign is because of the I squared, and that I squared is -1, which means you're going to be multiplying by -1, which, yes, will flip the sign. So you'll go from a -28i squared to a plus 28. Do not make that like leap of reasoning before you're ready. All right, now this is another multiplication one. And this is on purpose because it's going to come up in the next problem. So these are what are called conjugates. So that's a really important word that comes up a lot in algebra, and conjugates take this form: a plus b, a minus b. So you'll have the same terms a and b, but one group will have a plus sign, so the b value will be positive. The other group will have a minus sign, so the b group will be negative. And when you multiply conjugates, you end up with what's usually called a special case. So special things happen. So let's just take a look at this. These are called complex conjugates, just because they're conjugates of complex numbers, not because they're extra hard. So 2 times 2 is 4. 2 times -4i is -8i. 2 times 4i is 8i. And -4i times 4i is -16i squared. And what I want you to notice there is those two terms on the diagonal cancel out. And that is, again, because one of them was plus and one was minus. And so you multiply and they will cancel out, leaving you with 4 minus 16i squared. I squared. Remember, if you see an I squared, you substitute it out with the -1. -16 times -1 is positive 16, and 4 plus 16 is 20. And what I want you to notice is that that was a real number. Okay, so we ended up with a real number. If you multiply complex conjugates together, you will end up with a real number, because your imaginary numbers on the diagonal are going to cancel out, and your squared imaginary number will square to give you that -1, which is real. All right, so that's just like one of those special cases. Which brings us to division. All right, so I mentioned earlier, and I think I want the first blob here. Yeah, blurb, not blob, blurb. We cannot have a square root in the denominator. Thus, we cannot have an I in the denominator, and we must operate to remove it. So that is one of those rules of math, and it has to do with what square roots are. They are irrational numbers, meaning they are numbers that cannot be written as fractions. And since division is multiplication by the reciprocal, you cannot take the reciprocal of something that cannot be written as a fraction. It is not something that typically bothers scientists or engineers, but it will send mathematicians over the edge because it's technically written in a way that is impossible. So what we're going to do when we divide is we are, for the most part, simply going to be operating to remove the I from the denominator. So how are we going to do that? We will multiply the number by the number 1 in the form of a complex number over itself. So here's our general strategy with that. Anything except for 0, okay, and we're just not dealing with 0 right now. Anything over itself is equal to 1. So if I take that fraction and I multiply it by the number 1, okay, I just did a huge one there. If I multiply, there we go, that's better. Multiply it by the number 1, I will get an equivalent fraction. So I am going to multiply by the number 1 in the form of something over itself. Okay, so what is the thing? Well, we're going to choose the conjugate of the denominator for our complex number. Why am I doing that? Because as we just saw, if you multiply by the complex conjugate, you'll be left with a real number, which means that you will no longer have an imaginary number. So in this problem, the conjugate of 6 minus 7a is 6a. 6 minus 7i is 6 plus 7i, and I need to multiply by something over itself. Now we just got to go through and do that multiplication out. So I am going to do the scratch work for that off to the side. So we have 3 plus 4i and 6 plus 7i. For our numerator. So we have 18 plus 24i plus 21i plus 28i squared. So that'll be 18 plus, got something big here, what is that, 45i plus 28, and then I'm going to take this, like I'm going to collapse some steps here. Instead of writing 28i squared, I'm going to remember that I squared is equal to -1. So this will be 18 plus 45i minus 28. And at that point, I feel pretty comfortable moving back over to the main body of my problem, because 18 minus 28 is -10. So we have -10 plus 45i. And then my denominator should come out really, really nice. In theory, it should come out really nice because we're multiplying by conjugates. So we'll have 6 minus 7i times 6 plus 7i. So that'll be 36 minus 42i plus 42i, remember that's the part that cancels out, minus 49i squared. These guys cancel out. So I have 36 minus 49, and remember that substitution, so the I squared is -1. And essentially what we have there is 36 plus 49. So 36 plus 49, and now I'm going to hop back over to the other problem, and I believe that is 85. Now, a lot of times this is the point when you're done, okay? So there's a lot of scratch work over there. Okay, so much fun, but not impossible. I mean, this isn't like a massively hard problem. I've been on this slide less than 5 minutes and I've done a lot of explanation. So now I do notice that this can be simplified. And what I see looking at that is that all of these numbers are actually divisible by 5. So 10, 45, and 85 are all divisible by 5. So I'm going to go ahead and factor a 5 out. So if I take a -10 and factor out a 5, that'll leave me with -2. You could also think if I distribute it back, 5 times -2 would give me that -10. And then 45, factor out the 5, and you get a 9. And then this one, when I was doing it out earlier, I did have to do a little bit of work on that. I believe that is 17 times 5. Okay, that's not one that I just know it's divisible by 5. I had to go out and do the division. I was like, 17 tables, I don't actually know off the top of my head. And now we can see the common factors. So we can see, there we go, that's 5 over 5. And so the simplified version of this would be -2 plus 9i over 17. Or you might see it written this way, -2 over 17 plus 9 over 17i. And that step is just that formality of putting it into a plus bi form. Most teachers would probably accept that as the answer, because if you got that far, you just navigated a whole lot of complex number stuff. But you might but if you're doing a computer-based test, particularly like a kind of state test or something where you have to input it in, you have to actually type an answer in. If it's expecting it in a plus bi form, then you could get zinged if you don't put it in that form. So be mindful of the directions your teacher gives you, as well as what kind of assessment or test that you're taking. So a few tips before I leave you to the practice set. Always pay attention to the operator. Complex numbers often have parentheses around them, but there may be a plus or minus between them. So I wish I didn't have to tell you this, but I've seen it too many times. I have seen students take a problem like that, okay, which is clearly an addition problem. So all they need to do is combine like terms. Most of you can do it in your head. That's going to be 5 minus 1i, but they don't see the plus sign. They just see parentheses. Parentheses mean multiplying, and they do the multiplication out instead. And the multiplication not only does it take you way longer to do, it's also completely wrong if you multiply instead of adding. So please, please, please don't make that mistake. That is teacher me just talking to the internet. Like, don't do that, okay? Pay attention to the operator. If it's adding, add. If it's subtracting, subtract. And if it is multiplication, then knock yourself out and do it. Treat the I as you would a variable, okay? It's not a variable, so don't say that it's a variable. It's not varying. I mean, I is always that, so there's nothing varying about that, but it does behave like a variable in the work. Remember that I squared is equal to -1. I see a lot of I is equal to -1, which is just misremembering the content. Typically that will happen at the end of a unit when it's been a while since you've looked at it, or when you're reviewing for a final exam and the information is kind of old. But I squared, it is I squared, that is equal to -1. If I is equal to -1, like I don't need that number, okay? We already have a -1. So we don't need another -1. It's the I squared, that's -1. And just if you're dividing, take it slow. That should probably say take it slowly. But if you're dividing, take your time with that division. Do not try to rush it. Don't try to rush the thought process on that. And that's it. So please give this video lesson a thumbs up if you found it helpful. Be sure to subscribe for more math help. Check out the practice set as well as the other videos and lessons on the channel, and drop a comment or question to engage. And I hope to see you in a future lesson.